This is lesson 5.4, isosceles and equilateral triangles. The goal for this lesson, I can use properties of isosceles and equilateral triangles. So what is an isosceles triangle? Well, an isosceles triangle has two congruent sides, and those sides are referred to as the legs. So if you look over here at the drawing to the right, the not the base, but the other two sides then are legs of the triangle, because we're going to say that they are the congruent pairs. So I'm going to put a couple of congruency marks on there like this to let us know they are congruent. The legs form what we call the vertex angle. So this is the vertex angle, or angle 1. The third side is the base, and these two angles along the base are called the base angles. Okay, so that's the anatomy of an isosceles triangle. You've got two sides that are legs. They are the congruent sides. You've got a third side called the base. The two angles at the base are called base angles, and the angle formed by the two legs is called the vertex angle. So what does the isosceles triangle theorem say? Well, if we know two sides of the triangle are congruent, then the angles opposite them have got to be congruent as well. So here's our legs, right? So if the legs are congruent, it is the base angles that are also congruent. So we could say angle B is congruent to angle C here. So if we know two sides are congruent, we can conclude the angles opposite them are congruent. And then the converse of that switches, remember the if and then around. We learned that back in the logic unit. So I could say if two angles are congruent, then the sides opposite them are congruent. So in this case, I can say that segment AB is congruent to segment AC. Okay? So you can just work it both ways. All right, so equilateral triangles, what are those? Well, that's all sides that are congruent. So we've got, somehow we're going to mark that. We can number them with the same length, like maybe they're all measuring 5, or you've got this, the hash mark that we always use to indicate congruency. A triangle is equilateral only if it is equiangular. Well, equilateral, lateral just means sides. And you can see the word angle in here, okay? So this is saying equal angles. So in an equilateral triangle, we already know the measures of the angles. They're always 60, okay? Never are they any other measure, because they have to share 180 amongst the 3. So if you divide 180 by 3, you get 60 degrees apiece. Okay? So find the value of x in each triangle. I think the important thing about isosceles and equilateral is identifying them when you see a drawing. So in this drawing, these red marks in the corners tell me that those angles are congruent. So this is the base now, up in the air, and these are my legs, and so opposite my base angles, you're going to find those two sides, so this side must be 7 as well. On this figure here, we know the two sides are congruent. We know these base angles then are congruent, and so if this angle is x, this one is also x, and I know if I add those together with the 40 and set it equal to 180, I'll figure out the value of x. So I'll subtract 40, that's 140, I'll divide by 2, and each of our base angles then are 70. 70, 70, and 40 add up to 180, okay? So again, it's just recognizing with these markings that you've got isosceles triangles. You try these two. Hopefully you pause the video. Across from these two angles, you're going to find these should both be 6. And in this drawing, we've got two sides that are congruent while the angles opposite are congruent, so x is also 75. Try these two. Well, through subtraction, you could find out that 60 plus 60 makes 120, and then 180 minus 120 makes this 60 as well. So this is an equilateral triangle, equiangular triangle. So all the sides are 12 because this side's 12. So FH is going to be a 12. Find the measure of angle MRP. Well, noticing that these three sides are all equal makes it equilateral, which means it's equiangular, and every angle is 60 degrees. Example 2, a little bit of algebraic expressions in here now. Okay, so we've got a couple of 8s. These two sides are 8. Therefore, these two angles are equal. So I can say 4x minus 2 equals 62. I can add 2 to both sides. I can divide by 4. And I get 4 goes into 64. Is it 18? I better use my calculator. 64 divided by 4, 16. So x is 16. Okay. Give this one a try. All right, hopefully you paused the video and tried that. Sometimes you're going to be given the information and you should probably mark it in the drawing like this. Now I know that across from these two congruent angles, I'm going to find a pair of congruent sides, which means they are equal. So 3x minus 20 must be equal to 2x plus 15, and I'm going to subtract 2x, and that's going to give me x. Then I'm going to add 20. That's going to go away, and I'm going to get 35 for x, and that's what they're looking for. Find the value of x. Okay. Your assignment then is an IXL L10, looking for a SMART score of 80.